All right, party people. So rational equations, take notes, pause this video as you need it to be. I'm going to show you 4 examples that resemble very much like your homework. Okay. So I'm looking at this equation and you might be intimidated like, oh man, this looks complicated, right? But it isn't. The first thing that you got to focus on is making sure that you have all the common denominators. Okay, find common denominators. So in order to do that, and this is going to be the same for all of them, is I would break down, right, these denominators by their factors. Okay, which means you see how this is multiplication right here, right? 2x is 2 times x. So those are 2 factors. This is a factor, that's a factor. 3 times x, that's a factor, that's a factor. And then you got 6 times x, which is also factors. But what I'm going to do with that 6x is I'm going to break it down to its prime factors. So check it out. I'm going to put 2 times x, right? I'm going to put 3 times x. But the 6, I'm going to write it as 2 times 3 times x, right? Now, you're looking at these 3 denominators, and you will notice that they have some common ones, right? They got some common factors, like they all have an x. Great. There's also some common ones, but not for all. For example, you got the 2, and this one has a 2, right? This one has a 3, that one has a 3. So this denominator has all the factors that the other guys have, but the other guys are missing a few. So what I'm going to do is, in order to have them all the same factors, I'm going to have to multiply a 3 to this. That way it has all the ones that this one has. Now they both have the same, right? And I'm also going to multiply this one by, you guessed it, 2. That way, now this one has all the ones that this one has. You can see that now all 3 of them have exactly the same factors. But here's the thing. If I multiplied a 3 down here, then I also have to multiply a 3 up here. And you know what? I'm going to change it to parentheses because I might have to distribute later. Okay, so I'm going to change it to parentheses. Because again, I might have to distribute later. Right? Times 2x plus 10. Now, this one already had all the factors that the other guys had. So since I'm not going to change the denominator, I'm also not going to change the numerator. Numerator stays exactly the same. So then now you're going with, okay, over here I got a 3. Over here, and because it's a plus, which is very important, later on we'll talk about the negative, it's just going to be a distribution, which is plus 4x plus 20 equals 2. And remember, I didn't change anything about that, so I'm just going to give it a 1. Now, what about the denominator? Well, since all the denominators are all the same, I no longer need to worry about it. Okay, that's the beauty of it. You could put it all under 6x if you want to, but you don't even need it. Okay, you don't need it for the for solving this equation. Okay, so at that point, when all the denominators are the same, they're common, just worry about the numerator. From here on out, it's just a regular equation, right? Combine like terms, 4x plus 23 equals to 1. By the way, a lot of your answers are going to be factors today. I mean, fractions, not factors, fractions, right? So you have 4x equals to negative 22 divided by 4 gives me negative 22 over 4, but it simplifies to negative 11 over 2. So that right there is your final answer. Okay? I would say, hey, normally if it was in class, I would say, hey, any questions? But if you do, hit me up later. Okay? Any questions with that? Again, keep it in mind. Key here is having the same denominators. That's key, okay? So let's try it again. You can pause the video right now if you want and you try it on your own, or you can just go ahead and watch me do it, okay? So if you take a look at here, you have this 5, and I'm gonna write it a little bit higher. You have this 5, and the 5 is the only one that doesn't have a denominator. Actually, it does. It is an invisible 1, right? Now, the other two have the exact same denominator. So what is the denominator that I need to multiply by with this one? Well, to make it the same as the other ones, it's going to have to be times s plus 6, right? That way, I get the same denominator, which means I also have to do that at the top as well, right? But what kind of multiplication is this going to be? Very good. It's going to be a distribution. So then I have 5x plus 30. And did I change the denominator here? No. Then I'm not going to change the numerator either. So it's going to be plus 3. Did I change the denominator here? Nope. Then I'm going to keep the same numerator. Okay. If the denominator doesn't change, the numerator doesn't change. If the denominator changes, then it's got to change the same way in the numerator, okay? All right, now, again, all the denominators are exactly the same now. Everybody has the same denominator, so I don't even need them, okay? Don't need it at all. Again, from here on out, it's just a regular equation, 5x plus 33 equals to 1. Subtract 33. I end up with 5x equals to negative 32. Divide by 5, and you end up with this nasty fraction. Right? Cool? All right. Let's go with the next one. It looks a little bit more complicated, but again, the way I want you to write this is I want you to break them down into their factors. Okay? So the first one, can't break it down much more than that. The second one, any GCF? No, so it's just going to be like that as well. But you notice that this one does have a GCF, and that GCF is an X. Very good. And guess what I have inside? X minus 1. Oh, wait, yeah, no, sorry, it's minus 3, right? To kind of X, very good, right? So what do you notice now? You notice that this guy has the X that this guy has, but he also has the X minus 3 that the other guy has. So now these two guys are just missing one item that the other one doesn't, right? So what is that? Well, this guy is missing the X minus 3. So I'm going to do that. And this guy is missing an X. So I'm going to do that, right? And all of your problems are going to be very similar. I'm not going to make it too complicated where, you will see that pattern like, oh, this guy has this factor, that guy has that factor. It's not going to be all like, this guy has 3 different factors and this guy has 3 different factors. No, it's just going to be maybe 1 or 2 differences here. Okay. So now we take care of business. This is super easy because it's a 1. 1 times x minus 3 is just x minus 3 equals 2, right? 1 times x. And did I change that? No, I did not. But what I also want you to pay attention to is this negative, which means you are going to distribute that negative to both of them. Okay, so that's a very important thing when you're doing subtractions. Okay, the addition, you don't have to do it much. You don't have to change much with addition. Right? You ain't got to worry about it. But subtraction, you definitely have to distribute. Okay, so write it down. Subtraction problems. Subtraction problems need negative distribution. Okay, so just remember that. So that means that that becomes a negative 3x, and the 6 also becomes a negative. Okay, because originally they were positive, right? So from there on, check it out. Combine like terms, negative 2x minus 6, right? We bring those two together. I'm gonna go ahead and add 2x on both sides. You get 3x minus 3 equals to negative 6. I'm gonna go ahead and add 3. 3x equals to negative 3. I'm gonna divide by 3. X equals to negative 1. Okay. How are we doing so far? We good? So again, the most complicated part is making sure that the denominators have the same factors. Okay, so that's what is key there. Okay, so let's try this again. New problem. All right. All right, so here we go. Number 4. Hopefully, here, the original problem goes like this: x squared plus 3x. Okay, so hopefully by now you can see, oh, all right, I see what they're doing. You know, you got these two, and if I were to distribute them, I would get that, right? So with the way that I can break down the GCF here, right, is to say, oh, x times x plus 3, right? That way, they all sort of could have the common denominator, right? So again, what is missing on this one is an x plus 3, which I completely understand you're gonna hate me for this. Here, let me move this over a little bit because I need a little bit more space on that. Right, and you're not gonna like multiplying that, but I'm gonna have you do it. All this is missing is that x, right? That's all that is missing. And this one, fortunately, is not missing anything, right? So we're gonna keep that intact. Now, when you multiply these two together, right? And if I were to do the x plus 3, x minus 2, I would end up with negative 6, negative 2x, would have positive 3x and x squared, right? So I have x squared plus 1x minus 6, okay? So I have this x squared plus x minus 6 equals to, right? Equals to, and then that becomes 6x, and we're gonna bring this down, but remember, you see this negative right here? That means that we have to distribute that negative to this one, and to that one, which means they all change symbols. So it's going to be negative x squared, positive x to the 4x, positive 12. Okay. And again, at this point, I don't need the denominator because I know that everybody has the exact same denominator, okay? So let's go ahead and just get this monstrosity. I can do a couple of things. I can combine like terms right here. So that's gonna give me x squared plus x minus 6 equals to 10x minus x squared plus 12, right? Now let's go ahead and make it equal to 0. So I'm gonna add x squared here, I'm gonna add x squared there. I'm gonna subtract 10x here, I'm gonna subtract 10x there. And I'm gonna go subtract 12 here, I'm gonna subtract 12 here. So at the end of the day, right, if you did this correctly, all of these give you 0, which is what you need in order to be able to solve for quadratics. Here I got 2x squared minus 9x minus 18, sorry, minus 18. Okay. And now let's go ahead and factor it because all of them are, now you could use the quadratic formula if you want. I mean, that's totally up to you. You can do either one. You could do negative b plus or minus square root of b squared minus 4ac all over 2a. Whatever you're more comfortable with, you do. Okay, I'm gonna use a factoring method and the ZPP, the zero product property. Okay, I'm gonna use that method, but you could totally use the quadratic method, quadratic formula. Okay, so let's see, we have negative 36 here because I multiply a times c, that's 2 times 18. I get negative 9 here because that's b. I know that this is going to be a negative, this is going to be a positive. And if I were to do this, it would be negative, positive 1, negative 36, positive 2, negative 18, positive 3, negative 12. And that is my combination that I want. It's going to be 3 and 12. I'm going to try to simplify by the a, which is 2. And so the first one can be simplified, so I end up with 2x plus 3. And the second one can be simplified, gives me negative 6 over 1, which gives me negative 6, which gives me x equals that, x minus 6. Now remember, the zero property rule, a zero product property says, hey, you got to make this equal to 0. Because you're not done, you just found the factors, right? So remember, that's where that 0 comes in. So I'm going to go ahead and subtract by 3. I know it's like, what? This is a lot of work, Mr. C. I know, I can hear your voices. And you might have like skipped through this already. But it is this answer right there. That's 1. The second one is much easier. So the last 2 problems in your homework are quadratic. Okay, so you will have to go through this monstrosity. If I were to use the quadratic formula, it would look like negative 9, 2, 2, negative 18, right? That's positive 9 plus or minus, and this gives me 81. Right, and that gives me 8 times 2, 4 times 2 times 18 was 4 times 2 times, times 18, 144 plus 81, 225, right? And guess what? 225 is a perfect square, which is plus or minus 15 all over 4. So I'll say 9 plus 15 over 4, 9 minus 15 over 4. That gives me 24 over 4, which gives me 6. So these are the same, right? This gives me negative 6 over 4, which divided by 2 gives me negative 3 over 2. And again, they give me the same answer right there, right? So I don't care which method you use, you should end up with the same answer, okay? That's it. If you have any questions, go ahead and let me know when I get there.